We're surrounded by devices that work with electricity. Those devices are used to transfer information, sense our environment, or just to emit light. However, we have probably never thought about what exactly electricity is, which makes those magic devices work, and what concepts like voltage or resistance are. In this video, I will explain the main concepts that we need to know when first getting started with electronics. My name is David from Dotmatic, and let's jump right in. Concept number 1. Voltage. I think the easier way to explain electricity is using a water analogy, so let's use it in this video as well. To understand voltage, let's think about two water containers with different water levels. Now, let's connect them using a pipe, and hopefully, the water will start to flow from the container with a higher level to the one with the lowest level. This is due to potential energy difference. Potential energy is the energy that a body possesses in terms of its position against another object. For example, if you hold a ball in the air, potential energy will be m times g times h, where m is the mass of the ball, g the gravity of the earth, and h the height where the ball is being held. So, if we take a closer look, we can see the gravity and the mass of the ball are constant. This is because the gravity is the same in the earth, and the ball is gonna be the same ball. So the potential energy in this case depends only on the height where the ball is being held. So the ball has the potential energy because it has the potential to fall. That means to make a displacement from the point A to point B. So going back to the water analogy, the water in container A has a higher potential to flow to container B when a pipe is connected, since the water level is higher. So it means there is more water pressing down against the other container, and water will begin to flow until the container A loses all its potential energy regarding container B. In this case, that's called pressure, the force water produces onto a surface. In electricity, we don't talk about pressure, but voltage. The voltage is the energy needed to move an electric charge. For example, think about a battery. It has two extremities, one marked with a negative symbol and the other one with a positive symbol. So picture container A being at the positive pole of the battery and container B at the negative one. So when they are connected using a pipe, water will flow, but in this case, a wire. And instead of water, electrons will move. So voltage is defined as 1 joule of energy per coulomb of charge. This is the conventional way of seeing electricity, moving from positive to negative. However, since electricity is a force of attraction that makes positive charge attract negative ones, and if you remember your school class about the atom, then you will know positive charge don't have the ability to move, only electrons do. So actually, the electrons will move from the negative pole to the positive one. In conclusion, voltage is the potential energy difference that has the potential of moving electrons from one point to another. Concept number 3. Resistance. As in life, not everything is that easy, and so it is for electrons. A pipe may have imperfections or reductions that may cause the water flow to lose energy, pressure in that case. In the same way, there are materials that because of their atomic structure, it's harder for electrons to flow. All that makes it harder for electrons to flow is called resistance. In electric circuits, there is a common component called resistor, and as it can be inferred, its stack is to oppose current, which causes the loss of some of the voltage initially induced by a battery or a power supplies across it. A resistor is a representation of any component consuming electrons' energy. For example, in an LED, the energy that electrons lose is converted into light, and in an oven is transformed into heat. The resistance is measured in ohms and is equal to voltage over current. At the end, if we do some of the, algebra, we're going to have the resistance is equal to joules per unit of charge times seconds per unit of charge. This means that resistance is the energy per unit of charge needed in 1 second to deliver 1 coulomb. In other words, how much energy per charge you will need given a certain resistance if you want to make 1 coulomb of charge passes through 1 second. In real life, the devices have a nominal voltage and current. This tells how much voltage we need to overcome the resistance that the device represents and make a certain current move through it, so that device can have the energy needed to do this work. Concept number 4, power. My keyword to explain power is ability. In the water analogy, we can think about the water flow moving a turbine for a certain time until the 2 containers have the same levels, and the water stops. In electricity, power is the ability the current produced by a voltage possesses to do work for a certain time. This means how much energy can be delivered in a given time. The work can be, for example, turning a light on, making an oven dissipate heat, or even moving a motor. Electric and electronic devices usually have a nominal power, which tells how much energy they consume. Power is defined as voltage times current. And if we do some algebra, we're going to have that power is joules per unit of time. So, as I said before, it means how much energy is being delivered in a certain time, in this case, seconds. So, when you see the nominal power of a device, for example a 60W lamp, which stands for 60 watts lamp, it tells it consumes 6 joules of energy per every second it's on. Concept number 5, circuit. Electrons themselves can do any work. Think about a battery, which isn't useful when it hasn't been connected to anything. A circuit is a closed path for the current, so it connects, for example, the positive pole of a battery with the negative one. The path can have different components across it, where the electrons will be doing the work. A circuit is what gives purpose to electricity. So we've made it to the end of the video. Voltage is the force that pushes electrons. The current is the flow of electric charges forced by a voltage. Resistance is the force that counteracts voltage, so it makes electrons to lose energy. And power is the energy that a current can provide for a certain time to do work, for example, turn your home's lights on. This was a basic resume of electricity concepts, an invisible phenomenon that is now all around us and makes our lives easier and happier. If you're an engineer, you probably know all this and even in more depth, but it's never too much to review the basics of any science and share that with people not too related to these topics. I hope the video was informative and easygoing. This was David from Dark Knight, and I'll see y'all in the next one.